Okay, welcome back. Looking at quadrilaterals, section 8.3 in your book, and page 173 of your book, page 8 of your log tables. Okay, let's start off by defining by making a quadrilateral first. So a quadrilateral has, it says it in the name, the word quad means four, or quadri means four, lateral means sides. So as long as you draw a straight edge, draw a slanted straight edge from that, a slanted straight edge from that, and then you join them all up, you got yourself a quadrilateral. Okay, so it has nothing, the sides are unrelated to each other, so they might be of length A, B, C and D, and the angles are unrelated to each other. So we'd have one angle, a different angle again, and a different angle again. Okay, A and C are opposite sides, D and B are opposite sides, and every quadrilateral has two diagonals. I think we didn't have it all in a triangle. Every quadrilateral has two diagonals that break the quadrilateral into two different triangles. Okay, and we know the sum of the angles in a triangle is 180 degrees, and so we can see here that the sum of the internal angles of a quadrilateral add to 360 degrees. Okay, you can make the typical quadrilaterals you're going to see are called concave, in that the internal angles are all ordinary angles. They're all less than 180 degrees. Okay, but you can make a convex quadrilateral very easily. You can just choose to buckle in one of the corners. Okay, and then you have what's called a convex quadrilateral. Okay, so we want to construct a parallelogram. We want to do the construction because it's just good practice. So what I'm going to do is I'm going to do a nice handy little trick. We'll take two parallel lines that are using a straight edge that's quite wide, and then we'll take, actually let me change how that's going to look so that it's a longer rather than deeper parallelogram. So let's use this narrower ruler first as my first straight edge, and then use a fatter straight edge like this. Nice handy trick to create a quadrilateral without getting into a huge amount of drawing skills, which we'll be doing in another chapter anyway. Okay, so here's my quadrilateral, and we need to talk about the fact that in a parallelogram, here's a parallelogram, the opposite sides are equal to each other, and we show that by putting two ticks, one tick for example on them, and then say two ticks on this one, and they're equal length, they're congruent, so opposite sides are congruent. So this word congruent is a word that's used in geometry to say things are equal no matter what they are, kind of thing. Two triangles are congruent if they have the same shape and size. Two line segments are congruent if they're the same length. Two angles are congruent if they're the same degree measure. Okay, so what do we see about the angles? Opposite angles are equal. I'll finish this later. I'll just pump this up for now. I won't do it actually.